Okay, we're combining functions in ever more complicated ways. Now, f and g are both rational. Let's see what that does to us. The domain of f would be any real number except we get interested in this denominator. We'd have to say x minus 1 is never allowed to be 0, which of course means x is never allowed to be 1. So that's the domain for f of x would be x can be any real number except not 1. For g of x, x minus 3 is not allowed to be 0, therefore x is not allowed to be 3. Put an XER in front of that. That's the domain for g. And now they give us this thing. This means 3 times f times g evaluated at 2. And I think the best way to handle that is forget about the 3 for a minute. We'll just get this part, f of g of 2, or f times g of 2, and we'll triple it afterwards. So f of 2 is 2 times 2 over 2 minus 1, which is 4 over 1, which is 4. G of 2 is 2 over 2 minus 3, which is 2 over negative 1, which is negative 2. So f times g of 2 is the product of these guys. It's 4 times negative 2, which is negative 8. And now they want 3 times that amount. 3 times negative 8 equals minus 24. Could you do all that in one huge step? Yeah, you could, but I generally prefer to do these things one bite at a time. So 3 times f of g of 2 comes out to minus 24. And then they says write an expression in simplest form for f plus g of x. Well, that just means take the two expressions and add them together. So f is 2x over x minus 1. And we're adding that to the g function, which is x over x minus 3. And they want this in simplest form. I don't think it's so bad the way it is, but I'll bet they expect us to get a common denominator and squish these together. So we'll multiply this side by x minus 3. And this right-hand side needs an x minus 1. And that results in 2x squared minus 6x, that's this numerator, plus x times x is x squared, minus x, that's all our numerator, and the whole thing is over x minus 1, x minus 3. I could FOIL this out, but I don't want to because they're asking about restrictions on x, so in a few moments I'm going to be talking about when this can't equal 0, so I'm not in any great hurry to expand this right now. Upstairs, 2x squared plus x squared gives 3x squared. Minus 6x minus another x is minus 7x. And that's all over x minus 1, x minus 3. So there's our expression. I think that's as simple as it could get. You could factor an x out of the numerator if you like factored form. I am inclined to do that myself, but it isn't necessary. And for restrictions on x, you would have to say x can't equal 1 because of this piece, and also x can't equal 3 because of the second piece. And last section, f over g of x they want now. So this means, I'm just going to write this a little differently for our purposes because I don't want to have a bunch of stacked fractions. This means f divided by g of x, which for us means 2x over x minus 1 divided by x over x minus 3. If I hadn't used the division symbol, I'd have 2x over x minus 1 over x minus 3, and fractions like that are just awful, so I try to avoid them if I can. This means the same thing, and it kind of shows us what to do next. You remember when you're told to divide fractions like this, you don't. Instead, you multiply, and you flip the second fraction over. So you get x minus 3 over x. So when we expand that, 2x times x is 2x squared. 2x times negative 3 is negative 6x. And then we get x times x, and we get x times negative 1. And I was saying up above that I didn't want to expand my denominator, and now I pay for it here. They want the restrictions on x, which means I would probably be better off if I pull that denominator apart again. Just leave it like this. Because what I must do now is look at when could this denominator equal 0. Well, it could if x equals 0, so we don't want that to happen. This piece is not allowed to go to 0. And from the second piece, we get x minus 1 can't be 0, which means x cannot be 1. Those are our two restrictions or non-permissible values.